By the end of this lesson, you should be able to write valid arithmetic expressions. Okay guys, we're slap bang in the middle of programming, so let's get stuck in straight away. Now today, we're going to learn about expressions. So, let's get the computer to do what it's really good at doing.
And what's that?
Arithmetic.
I should have guessed.
Now, do you remember when we learned about expressions in the spreadsheet lessons?
I do.
Do you remember what expressions consisted of?
Please remind us.
They consisted of operands and operators.
Operators are things like an asterisk for multiplication and a forward slash for division.
That's right. And Kamal, what do operands consist of?
Cell references like C4 and...
Literal values like 12 or 5.5.
And we can use text as well.
Correct. Now the same idea exists in Java, and most of the operators also look the same. Addition is the plus sign. Subtraction is the minus. Multiplication is an asterisk, and division is a forward slash.
That's the same as in spreadsheets.
Aha, so far. But there's no Java operator for percentages or exponentiation.
What's expo or whatever?
That's when you raise one number to the power of another number.
Do you mean like 5 to the power of 3?
Yes, and this is what it looks like in a spreadsheet.
I remember that symbol. In a spreadsheet, it's called an accent.
Well remembered, Morwa. Now, in Java, we use a method in a class called math, and it's stored in the Java library for use whenever it's needed.
Hey, there's a mistake in the division example. 5 divided by 2 is 2.5 and not 2.
Actually, Kamo, it's correct. Let me explain. Do you remember in the data representation lessons, we learnt about integers, whole numbers, and floating point or real numbers?
Integers don't have decimal places, but real numbers do.
That's right. And they're stored differently in the computer's memory. Now, also a computer, it uses different logic circuits to do arithmetic with integers and floating points.
Hey, didn't you say integer arithmetic was faster than floating point arithmetic?
It is. But when we were learning about spreadsheets, we didn't need to bother about the difference between integers and floating point numbers, since all the numbers were floating point numbers.
Now I remember. We could format the numbers to show no decimal places, or we could use the round or trunc function to make a number a whole number.
Correct. But remember, the number was still a floating point number. It just had zeros in all its decimal places. In Java, as in almost all programming languages, there's a difference between integers and floating point numbers. When we write a literal number like this 3, it has no decimal places, so it's seen as an integer. But as soon as I add a decimal point to the number, it's seen as a floating point number, even if it has no fractional part. In this division example, both the 5 and the 2 are integers, so integer arithmetic is performed and we get an integer result. That's why the answer is 2. Also, notice the symbols. We don't use an equals sign as it's an assignment in Java, not an equality. So, we use an arrow instead.
But what if we wanted the answer to be 2.5?
Well, if we make at least one of the operands a floating point number, then the other operand will be converted to a floating point number as well. Floating point arithmetic is performed, and the result is also a floating point number. So, if we take 5 divided by 2, we have 5.0 divided by 2. Floating point arithmetic is performed, and the result is 2.5. What do you make of that?
I get the floating point arithmetic, but I don't understand the percentage sign in this problem.
In programming, the percentage sign actually has nothing to do with percentages. We call it the mod operator. Now, it gives the remainder when the first operand is divided by the second. So, it's easy to understand with integers. For example, here we have 5 mod 2. What do we get when we divide 5 by 2 with integer division?
2.
And what's the remainder?
So that's how we get an answer of 1.
That's right. 5 mod 2 is 1. Morwa, you try this one. What is 17 mod 5?
Okay, 17 divided by 5 is, let me see, 5 3s are 15, 3, and the remainder is 2.
Correct. So the answer for 17 mod 5 is 2. When we use floating point arithmetic, we divide the first operand by the second to find out how many whole number of times the first operand is divisible by the second. For example, let's take 5.2 mod 2.5. We know that 2.5 goes into 5 exactly 2 times. So 2.5 would go into 5 2 whole times, and then there would be something left over. That something left over is the answer that the mod operator gives us. You can also work it out by taking the fractional part of the answer to the division, which is 0.08. Then multiply it by the second operand. That's the number you divided by 2.5. Now, we usually only use this mod operator with integer arithmetic. So please remember, it gives the remainder when you have divided the first operand by the second. And just as in maths and in spreadsheets, there is a certain order to the operations as they are performed. The division, multiplication, and mod operators have a higher precedence than addition and subtraction. This means that they will be performed before addition and subtraction. So, let's have a look at that example. 5 plus 3 multiplied by 8. First, the multiplication is performed. 3 times 8, which gives us 24. Then the 5 is added. 5 plus 24 gives us 29. Now, when operators have the same precedence, they're performed from left to right. For example, 6 multiplied by 3 divided by 2. Multiplication and division have the same precedence, so they're executed from left to right. Therefore, the 6 multiplied by 3 will be done first, giving the answer of 18. Then 18 will be divided by 2 to give an answer of 9. Of course, we can change the order of operations by using brackets. So, let's take a look at the example over here. 6 multiplied by, in brackets, 3 divided by 2. What would that give us, Kamo?
That would be 6 multiplied by 1.5, which
No, wait, Gamu. It's not 1.5, it's 1.
Why is that?
3 and 2 are both integers, so you must do integer division.
Oh, right. Now, 3 divided by 2 is 1. So 6 multiplied by 1 is 6. The answer is 6.
Well done, Kamo. And well done, Morwa, for pointing out the error. All right, guys. I think it's time to write a program. I want us to write a Java program which calculates what 50 degrees Fahrenheit is in degrees Celsius. The formula to convert from degrees Fahrenheit to degrees Celsius is to subtract 32, then multiply by 5, and divide by 9. But first, let's see how you'd write this as a Java expression.
Oh, that's easy.
Great stuff, Morwa. Okay, now let's open JGrasp and start a new program. Okay, let's call it temperature conversion. And please take note, guys, there are no spaces, and each new word starts with a capital letter. Well done, Kamo. Right. Glad to see that you remembered the documentation comment before your class with the purpose of the program, the author, and the date. And Morwa, I liked the way you typed the class header followed by the opening curly bracket, immediately followed by the closing curly bracket and the comment. Now you can go back in between the brackets and add the main method. Remember, it's public, static, void, main, open round bracket, string with a capital S, open and close square brackets, ARGS, close the round brackets, and add the comment, // main. Inside the main method, type system.out.println, open round bracket, double quotes, open round bracket, double quotes, 50 degrees Fahrenheit is, space, close double quotes, close round bracket, semicolon. On the next line, type system.out.println, open round bracket. Now type in the expression that calculates the temperature in degrees Celsius. And close the round brackets and add a semicolon. Now, add another system.out.println statement that will output a space and degrees Celsius. Right, now it's time to compile and run your programs. Are you guys finished? What answer did you come up with?
I've got 10 as the answer. Right. Yes, it's right.
Can't we put the output all on one line?
Yes, Kama, we can. And there are two different ways of doing it. First, we take out the LN from the end of the first two print lines so that it becomes print. Print is another method of the system.out object that we can use. It's exactly the same as the print line method, except that it doesn't finish on the beginning of the next line. Now, compile and run your programs again.
Yeah, that looks better.
I'm sure you guys will agree that although this program works, it's limited. So in the next lesson, we'll extend it to convert to any temperature. Now for today's task, I've got two questions for you. Firstly, find the value of num1 to num5 in each of the following statements. The second question has some expressions using the modulus operator. In the circle are the results of these expressions. See if you can match the correct answers to each statement. Well guys, that's the end of another lesson in programming. Go well with those tasks, and I'll see you next time.
Goodbye.
Thanks, Murray.